Hello everyone. In this video we will be discussing the second equation of kinematics, which is S equal to U times T plus half A times T squared. In this equation, S is the total displacement, U is the initial velocity, A is the uniform acceleration, and T is the time interval taken by the object to go from the starting position to the ending position. Before you watch this video, if you have not watched the video on first equation of kinematics, then I would highly recommend that you watch that video before watching this one. It will greatly help in understanding the concepts in this video. Let us consider a car is moving with a constant velocity of u meters per second and a uniform acceleration of a meters per second squared is acting on the car continuously. The car moves a certain displacement in t seconds. Now, the question is, what is the displacement of the car? Since the velocity keeps on changing, we would have to find the displacement of the car for small intervals of time and then add it all together to find the total displacement. These displacements can be obtained by multiplying the instantaneous velocities with the small time intervals. Let us divide t into small intervals of time, delta t, and observe what is the displacement during each interval. Since displacement is usually represented as velocity times time intervals, which are analogous to the length and breadth of a rectangle. Hence, the area of the rectangle formed with the sides as velocity and time interval gives us the displacement traveled by the car. In the first time interval, the displacement due to the initial velocity is u times delta t. This is because u by definition is the displacement traveled by the car in 1 second, and since our time interval is a small interval delta t, the displacement will also be proportional to the small time interval. Hence, the displacement is u times delta t. The acceleration also contributes to the displacement. Assuming that the acceleration increases the velocity at the start of the time interval, and the velocity remains constant during the interval, we can say that the magnitude of the increase in velocity is a times delta t, since acceleration by definition is the increase in velocity per second, and for a time interval that is a small part of a second, the velocity increase will also be a small part proportional to delta t. Hence, change in velocity is a times delta t. To find the displacement, we have to multiply this increased velocity by the time interval again. In the next time interval, the existing velocity is u plus a times delta t, which is the increase in velocity from the previous interval. And the increase in velocity due to acceleration in the current time interval is a times delta t. The combined displacement due to both the existing velocity and increased velocity is shown in the graph. Similarly, for every time interval, the contribution due to the existing velocity and the contribution due to the acceleration get added together to give the displacements at each interval. In the graph, we can notice that the red represents the initial velocity u, which contributes equally in all time intervals. The blue parts represent displacement due to acceleration. The top part represents displacement due to the acceleration of the current time interval. The remaining blue parts are the displacements due to the increased velocity during previous intervals. Now, the acceleration process is a continuous process, so we would need to consider an infinitesimally small interval. Then we can approximate the graph where we can observe that the displacement due to acceleration resembles the shape of a right triangle, whose area is the displacement due to acceleration. Therefore, we get the equation for the second equation of kinematics, S equal to u times t plus half a times t squared. Thank you for joining me in unraveling the mysteries of the second equation of kinematics. If you found this video informative and helpful, don't forget to give it a thumbs up. Share it with your friends who might benefit from this knowledge, and if you haven't already, be sure to hit that subscribe button and ring the notification bell to stay updated on more exciting explorations into the world of physics.